All right, friends, it is time for the third episode of preparing for your final exam. This first question is a doozy. You have to draw a smiley face. I highly recommend the highlighter, and then you can draw a smiley face however you'd like, really. There's no right answer to that one. Alrighty, here we go. I'm reading. Interest rate of 6. Aha, keyword, continuously. That tells me I need to use this formula. And after 30 years, okay. So this is my initial investment. That's my principal. So after I will have my principal, and then E, which is my base, and my R has to be changed into a decimal, so I move that over 2 decimal spots. And then it's asking me what is the amount after 30 years, so that goes in as my time. Now, if you have an older calculator, you got to tell it that that whole thing is in the power. And I should be able to just go 3,000 and then E to the 0.06 times 30 power. And I'm getting $18,148.94. 100% you need to know that formula. That's going to come up on the test. And then the key word for that one is continuously. Sorry, I'm looking something up on Schoology. Because you know what? That's what people do. They look things up on Schoology when they're wondering something. I'm wondering if I put the key on here for you guys. So that's what I'm double checking. And keep in mind, everything for finals is in the final folder. Isn't that brilliant? It is there. Okay. So I have now $4,500 to invest. That's awesome. My interest rate, quarterly, not continuously. So quarterly means 4 times a year. So now I'm using my other formula. These formulas would be such wonderful things for you to have on your cheat sheet. I plan on leaving that money in there for 10 years. That's my time. This is my principal. How much money will I have at the end? Okay, well, A equals the money that I started with. And the rate is now 0.045. And the number of times it's compounded in a year is 4. That number appears in both places, just like the N. And then the time I'm leaving it in there is 10. And again, those of you with older calculators need to make sure that your calculator is aware that that whole entire thing is up in the power. And then I can just go through, since I know all these numbers in this problem, and type everything straight in. And I'm ending up with $7,039, and it rounds up to 70 cents. Okay. So you want to make sure that you know those formulas. What is your favorite song right now? I have no idea. I don't know. I am going to go with Mary Had a Little Lamb, which is not my favorite song. So I guess I'm getting this one wrong. And you're getting this one wrong too if you didn't write that. All right. Evaluate. So really pay attention to the verbs. I talked about that a lot. Evaluate, rewrite, convert, expand, condense. In chapter 3, more than anywhere, that's really important. This is a chart question. So if you have your chart, great. This is asking me 5, because that's the base, to what power will equal 625. So if you go to your chart and look on there where 5 is the base and scoot over, that would have to be 5 to the 4th power. So your answer is 4 if you evaluate that. Okay, rewriting. Rewriting in exponential form is that whole going from log base b of an answer equals a power, and then writing it as base to a power equals the answer. We talked about this whole log rule thing. So you really need to know how to go back and forth between those. So in this case, I start with the base, which is always down in the basement. So 25, I go get the power, and then I come back around. Now, we didn't do a lot with these types of powers, but it's not asking you to do anything. It's just asking you to rewrite it. So I did do that. Then let's see what the next one brings. Solve. Solve is another good verb. Solving for x is what we do a lot here in mathematics class. So this is where we did 4 different kinds. And you have to decide if it's, first of all, you have to decide, is it a log type or is it an exponent type? And then with logs, is it on one side or both sides? And so on. And so you have to kind of think through that to know what to do. So in this case, I have a log of this plus the log of that, and then no logs on the other side. So I'm in this boat. I have a log problem with logs on one side. I need to condense these. So it is your job to remember that when logs are separated by addition, go back to your log properties. This is on your list, in your notes, everything. They go together using multiplication. So I take the x plus 6, multiply it by the other x, and it equals 4. All right. Now I'm going to go ahead and multiply these out just because it'll be easier for me. So I have log base 3 x squared plus 6x. And then I need to change it. I need to change it into exponent form because when you're stuck with logs, you change the form. So I get 3 to the 4th equals x squared plus 6x. All right. Now, that 3 to the 4th is going to be 81. And when I move it over to, because you can't solve a quadratic if it's equal to 81, you have to have it equal to 0. So I'm going to move this over by subtraction. And now I have no good news for you. Most people in class that kind of remembered this or looked it up got this far and then they couldn't solve it. Well, keep in mind that if something's not factorable like this, you have to go back to identifying your A, B, and C values and then using the quadratic formula, where you take the opposite of B plus or minus square root of B squared minus 4 times A times C. And again, this is from like algebra 1 on. So I always do this part first on my calculator. So I'm going to go 6 squared minus 4 times 1 times negative 81. And that puts me at negative 6 plus or minus the square root of 360 all over 2. Okay, well, the square root of 360 is apparently going to be negative 6 plus 18.97 over 2, or negative 6 minus 18.97 over 2. And so when I do those two things out, I get two answers. I get 12.97 or negative 24.97. But if you saw the key, I only had this as an answer. And the reason I can't use that negative is that when I plug it in here, it would force me to take the log of a negative, and you can't do that. You can't take the log of a negative number. It's not possible. So when you get a value, you plug it into the original and you check and make sure it doesn't force you to take the square root of, the log of a negative. Going to solve again. Now we did a lot of solving of different types. This is again a log problem. This is actually easier because this one's already condensed down. So I just need to change the format. So I get 6 to the 3rd equals 4x plus 5. 6 to the 3rd, according to my calculator or my chart, looks like that. Taking that away to the other side, I get, actually I don't need to do the equals 0 because it's not a quadratic. Sorry. So I'm just going to move this over. That'll be easier. I'm just solving this like algebra 1. And so when I divide by 4, my answer is either 211 over 4 or 52.75. And that's just going to be based on what the answer looks like on your test since it's multiple choice. It's not obviously going to give you both the fraction and the decimal. You just would look for whichever one's there. Alrighty. So I'm again having to condense these, and I have logs on one side. So these are separated by subtraction. So again, go back to your properties and remember that if they're separated by subtraction, you put them together with division. And then that's going to still equal the 3. So just like before, I have to change the format now and get rid of that log. So I have 4 to the 3rd equals x plus 4 over x. 4 to the 3rd is 64. And what we did at the time to make it look more familiar was we threw that over 1, and then we knew we could cross multiply. So we get 1 times x plus 4 on this diagonal equals 64 times x on this diagonal. So moving this over, I have 4 equals 63x. And dividing that out, I get 4 over 63. Sorry, said 4, so I wrote 4. So that's how my brain works. And then if you wanted to do that as a decimal, again, it's going to be whatever the test has, 0.06349, blah, blah, blah. But I honestly would probably put a fraction because it's the more exact answer. Okay, here we're going to be solving for time. We want an investment to double. So if this is our investment, this is P. Interest rate's 9, so we're going to be using 0.09. Compounded continuously, there it is, keyword. This is a PERT problem. So if we wanted to double and we started with 2,000, that means we're going to end with 4,000. So we end with 4,000. We started with 2,000. E to the 0.09t. Now your variable is up in the power. This is called solving an exponential equation. And that means like this part has to get alone. So to get rid of the 2,000, we're going to divide both sides by 2,000 and get a 2, which makes sense because it doubled. So now we're stuck. So we rewrite it using logs. So we would write log base E, so we write ln, because that means log base E. And then we're doing the opposite of that. Like, again, if you have something where it's written as base to a power equals a number, you have to be able to rewrite that as log of that base, and so on. So since the power is always over here by itself on the other side, that means that this is going to be ln2, because that's base E. We just don't write it. The ln implies that base E. And then equals the power. Well, now I can just go to my calculator and do ln2. And so ln2 is 0.6931. And then to get the t alone, I'm going to divide this out. So I'm dividing ln2 by 0.09, and I'm getting a time of 7.7 years. And again, multiple choice, so you find the most right answer, the best answer, the one that's closest. Okay, so let's see. The number of bacteria present in a culture is this. So, okay, they gave me the formula. This is an exponential formula because my power is in the, my exponent's in the power, my variable. So when I don't know that part, I have to use logs ultimately to solve. Let's see, I want 6,000 at the end. So I'm going to have 6,000. This is going to be solving exactly like the last one was in terms of the process. Keeping in mind that this is growing because it's positive. If it was a negative power, it would be losing value. But we started at 1,000 and are ending at 6,000. So it's good because that's a growth. So just like the previous problem, we have to isolate this thing that has the variable in it. So we divide out the 1,000. So obviously we have 6 equals e to the 0.276 t power. And then I'm going to change to log. So it'd be log base e, so ln of 6 equals, and then the power is alone over here. On my calculator, ln 6 gives me this, about. And then I can divide by the 276, the 0.276. And then I get the time is 6.49. It says to the nearest half minute. So this is going to be 6.5 minutes. And it said earlier on that time was in minutes. So I'm good to go. Alrighty. The number of bacteria in a culture is modeled by blah, where T is the time in hours. Okay, so this is kind of the tricky ones. This is where we have to do 2 phases because currently we know that we have like too many variables, things that we don't know. So they have to give us an example. And here's my example. N is 250 when T is 7. This is going to allow me to find K, but it's not asking me for K. It says, what is the time required for the population to triple? Okay, well, tripling is going to mean that in the end there's 300, not 250. The problem is I don't know either K or T. So I'm using this given information to find the K value. All right, so now I can solve this similar to what we've been doing. Get rid of this number in front so that I can isolate the part that has the variable in it. So when I do that, this is gone and I get 2.5 equals K times, E to the K times 7. So just like the other two examples, I'm going to go ahead and do ln of this side, and that'll cancel out my E to give me K times 7. So I can go ahead and find my K value by taking my ln of 2.5, make sure you close that parenthesis down, and then divide it by 7. And I get that K is 0.1309. That is absolutely not the answer to my question. That's just my rate of growth. And I'm glad it's positive because I'm going to be going from 100 to 300. I'm trying to triple, so I need it to get bigger, not smaller. So that was just to find the K. Now I can go ahead and answer their question. When will it triple? Meaning go from 100 to 300. So now I don't have two unknowns. I know the K, I just don't know the T. And now for about the fourth time in a row, I'm doing the exact same math because my variable's up in the power. So here we go. As always, coughing. Okay, then I'm going to take the natural log. I'm rewriting this as log base E of 3 equals the power. And so I go to divide this out. And I can do it all at once as long as I close that down. So ln 3, close that down, divided by 0.1309. And the time is 8.4 years. And I was just reading to see if it says like what to round off to, but it doesn't. So after about 8.4 years, it would have tripled. That is a doozy, but it's something we did at the time. So maybe something you want to take a look at when you have to go and use the example situation that they gave you to find that deterioration or growth rate. Okay. Half-life scares everybody. Don't let it scare you. Half-life simply means that if you started with 1, you ended with half. So this is the time of one half-life. It's very similar to what we did before because we don't have enough information, so we have to find that rate first. So think of it this way. If you started with 1 of something, E to the whatever the rate of deterioration is, and then the years, the time that it takes, which they told you, and then you would end with half as much. So we're doing what we've been doing to try to solve for this R. It's not asking us for R, but we need it in order to do what they're telling us to do. So dividing by 1 doesn't do anything. So I'm at 0.5 equals E to the, and you can write it however it makes the most sense to you. So I'm trying to solve for R, which is up in the power. So I'm going to go ahead and do the natural log equals, and then my power. So when I do ln 0.5, I'm going to write down what I've got. And it's actually negative, which makes me pretty happy because it's half-life. And so you're decaying. So it should be going down. And so I'm going to divide this out. And these turn out to be really small numbers. So if I divide this by 5,700, watch carefully because it actually says negative 1.216, blah, 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 and then E negative 4. So you have to be smart enough to go, oh, that means it goes 1, 2, 3, 4 to the left. So your R, or rate of deterioration, is negative 0.1230 to fill these spots, and then your 1, 2. That is the rate of decay. It's really slow because it takes 5,700 years to happen. That's pretty slow. That's even older than me. So now I finally can answer this question. This is a really good problem because I think that on the final kids go, oh, it's multiple choice. I should be able to read the problem and pick the answer. Not true. A lot of these, you're going to need to really grind through some math before you can get to a logical even guess at what the answer is. Okay, find the age to the nearest year of a sample in which 16% has decayed. Oh, this is super tricky. If 16% is gone or has decayed, that means you have 84% left. That is really tricky. So think of it this way. You start with 100, you end with 84 out of that 100. Now we know that the rate is this. We just are trying to find the time. When I divide that 100 out of there, I end up with 0.84, which is not surprising because of that 84%. There. And it's the same as all the other problems we've been doing. I have my t up in the power. So I'm going to go ahead and do ln equals, and then have my power here. And get that t alone by dividing out. Again, shut that down at the end before you divide. So natural log of 0.84, close it down, divided by negative 0.123012. So I am getting t equals 1,452.9. It said find the age to the nearest year, so the time would be 1,453 years would be my best answer on that. So do I think that's super easy? No. Do I think that you can do it? Yes. And again, multiple choice, so you want to use that to your advantage. 1453. Okay, well, I'm super excited that that is not one of my answers. Let me see what I typed in here wrong. I might have negative, hang on. I'm going to type it in again. ln 0.84 divided by negative 0.12312. I'll take a couple extra digits. I'm getting 1429 when I divide that. That makes more sense. So I get 1429.12-ish. So 1429-ish. So here's the deal on this. When you look up here, none of these are an exact hit because of, like, this number had so many decimals in it. It went, I don't remember now, I can't see it. I guess it went 0.000126047. And so by getting rid of those numbers, it affects your answer. But this answer is definitely closer to this than any of the others. So when you're using multiple choice, you have to kind of be smarty pants about that. So, I missed a whole bunch of stuff. Wow. So I must have just gone down the line because I'm me. All right, well, that's fun. We're going to go back now and do stuff that's actually easier. Sorry. So evaluate. All right, well, there's only two ways to evaluate. I either use my brain or my calculator. And this is asking 7 to what power is 2/3. Can't use my chart. So I have to think back to that change of base where you have this. You can type it into your calculator as this log divided by the other. So in my problem, I'm going to go ahead and do the log of 2/3, close that parenthesis, and divide it by the log of the base, which is 7. So log 2/3, shut her down, divide by log 7, and I'm getting negative 0.2084. And, you know, don't worry about, like, how many decimals should I use? It's multiple choice, so just match what they've got. Okay, keeping in mind that back in the day when we did this, we said you can't use radicals. You have to start thinking that as x to the 1/2 power. So logs and powers are related to each other, not radicals. So when it says to expand, this is one of our verbs, expand, condense, solve. Really important to pay attention to those. That's why on the list for this chapter, they're all highlighted. So this is the same as asking log base b of y to the 3rd over p to the 2nd, all to the 1/2 power. It asks you to expand. So when you expand, you got to get that power down in front. That was one of our properties, the third property that you're supposed to know and probably have on your sheet. So I'd have the 1/2 out in front. And then I have the log of these two things that are put together with division. So according to that piece of my notes from that piece of paper, I separate them using subtraction. So I'd have the half out in front of the log of y cubed minus the log of p squared. And then I also have to get rid of these powers. So they have to drop down in front. The reason the 1/2 is outside of parentheses or brackets is it's affecting everything just like the root was affecting everything earlier. So now I'd have 1/2 out in front of 3 log y, because you can't have any powers in front of, these are all base b, sorry. You can't have any powers if you're expanding. Log base b of p. This is a legitimate answer. And then you can take it and write it differently. If you distribute this, you might have gotten 3/2 log base by minus, and then here a 1/2 times 2 would just cancel. So it would just be minus log base b of p. So again, multiple choice. So you look for whichever one of those you get as an option. Going the opposite direction and doing condensing, you got to get these numbers back up. You're like packing up. I talked about it like, unpacking or repacking. Here I'm packaging it all back up again so that that second power has to go up here. And then here I'm going to go ahead and take that 3 that's down in front and bring it up into the power. These are separated by adding, so they need to go together in a multiplication. And then you can stop there because otherwise you would have to do x minus 1 times x minus 1 times x minus 1, which would be a lot of multiplying, and then still multiply it by the x squared. So we're going to call it good right there. Solve. Okay, this is the kind where x is in the power, but I can get the same base. And I know that because I look at my chart and I see that 8 and 4 are both powers of 2. So 1/8 would be written as 2 to the negative 3 because the negative flips it over and the 3 turns it into an 8. And over here, the 4 would be written as 2 squared. But that square joins what's already up there in the power. Now that I have the same base, I actually can just cancel it out. And I end up with an algebra problem that you should be able to solve from like back in the day. So I'm going to distribute my 2. And go ahead and solve from there. And here I'm just going to leave my answer as a fraction because it's 100% accurate. It's not rounded off or cut off or anything. Negative 7/12 is what I get for my answer. Okay, this one's tricky and I cannot get them the same. 7 and 5 are not in the same row on my chart. So I am going to have to use my calculator and my big brain because this one's got a lot going on. So I have to get the powers down in front. So I'm going to go ahead and log this side because whenever you're stuck and you can't get at a power, you need a log to come along. Because now I can use my log properties to drop that power in front in both cases. And now I'm going to go to my calculator and find out what the log of 7 is. And it's 0.8451-ish, and that's times x on this side. And then over here, I'm going to be distributing. So when I do log 5, I get 0.6989x. And then I'm going to be multiplying that by the negative 4 as well, which is minus 2.7959 basically. So now even though it's icky, I can at least solve it. So I bring these over because they're x's. So I bring them over with the other x's, combining like terms. So I'll have my 0.8451 and I'll subtract the 0.6989. And then I'm at 0.1462x equals this number that was still out here. Oops, I didn't really leave very much space. Let me try again. What did I say? 0.1462 equals negative 2.7959. And I forgot my x. So to get x alone, I'm going to divide out that 1462. So 0.1462. So my x is going to be whatever, negative 2.7959 divided by 0.1462 is. So I'm getting negative 19.12-ish. And again, however far they round off, you know, you're looking for your best match. All right, more solving. X is in the power. I'm going to go ahead and move this over. So I have 5e to the negative 0.04x equals 30. I am trying to solve for x, and 5 is multiplied by that, so I'm just going to divide the 5 out. And now this looks like a lot of the word problems we already did because I have my x up in the power. So I rewrite this log base e, so just ln, of my answer equals my power. So I go to my calculator and I'm going to go ahead and just do that math. You got to stop freaking out every time it says log or ln. It's just a number. So I go to my calculator, ln 6, shut that down, and then divide by negative 0.04. And I'm getting an x value of negative 44.79-ish. And this is multiple choice, you guys. And so I can even try that and plug it in for solving ones and see if it works. And then I already did the rest. I just did them out of order because who knows why. All right, so that's a lot, but hopefully it helps. And maybe you only had to watch a couple parts here and there.